Hello students, welcome to Diksha Karnataka YouTube channel. So, today I am going to discuss about the chapter electrostatic potential and capacitance, and let me see how many of you are here. Harija is saying good evening, Soumik Sir, good evening Harija. So, if you are here, please give me a thumbs up so that I can see you. Okay, as I said, it takes some time to sync. So, I hope you can see me, right. Yes, yes, classic the classic Lithasa. Good evening sir, good evening classic. So, I will start with today's class, that is electrostatic potential and capacitance. As usual, we are going to discuss some MCQs, some very important MCQs which might come in your upcoming PU board exam, as well as some easy level KSET exam as well, because the questions are obviously we have compiled it from some from your PU board model question paper. Then we also have from your question bank, then we have some easier KSET previous year questions as well. So, everything is included in this lecture. So, the first question is simple and easy. Name the physical quantity whose SI unit is joule per coulomb. So, let me see how many of you can answer this question. Rocky, hi sir. So, please read this question. I already read it. Name the physical quantity whose SI unit is joule per coulomb. Option A is power, option B is electric field, option C is electric potential, option D is dipole moment. So, now let us see. Hema, hi Hema, classic Hema, both are answering option C. Yes, it is electric potential. Just a second. So, yes, electric potential. Why electric potential? Because joule is the work done, and joule per coulomb is the work done per unit charge, which is electric potential. Okay. Thank you. Let us move on to the next question. First few questions I think should be easy for you. Next question is dash is a unit of energy. Another easy question, even though it is not super directly related to this question, this chapter exactly, but concept actually coming from this chapter only. So, that is the hint I gave you. Hello Monkey D Luffy, hi Monkey. Yes, One Piece fan, I can see he is here. Hi. Yes, yes. Now answer this question, Luffy. This is easy question. Pooja is saying option D. I will wait. Yes, classic. One more important thing, whenever you are answering Pooja and anyone else who is just started this video, mention the question number, like watch classic has mentioned the question number, then the option. That is the correct way to represent, because when I am streaming live, that does not mean it is exactly like a video call, right. So, when I am stating something, there is a time lag of 10 seconds. So, whenever you are mentioning the answer, mention the question number, so that I know, even if you are answering a previous question or you are answering the current question, then I can see your response and reply accordingly, right. Yes, the unit of energy, electron volt is an unit of energy, very interesting. Electron volt is basically joule converted into electron volts for smaller units, for units of electrons, for energy occupied by an electron. In terms of that, we represent electron volt. So, electron volt is an unit of energy. Yes, correct answer. Pooja, yes, yes, correct. Now, next question. Equal charges are given to two spheres of different radii. The potential will be more in bigger sphere, be more on smaller sphere, be equal on both spheres, depends on the nature of the material of the spheres. Okay. So, here we have two spheres. Suppose one is a bigger sphere of say radius capital R, another one is a slightly smaller sphere, say of radius small r, okay, and both of them are given the same charge. capital Q here, capital Q here. Okay. Both the spheres are given same charge. Now, you tell me which one will have the greater potential. Both of them has same potential. So, basically say the potential of this is V1, potential of this is V2. Okay. So, it is saying that first option says thus it is more, that means V1 is more than V2. Okay. So, V1 is more than V2, it is saying V2 is more than V1, it is saying V2 is equal to V1 or something else. So, let us see who is the smartest person. Pooja is saying 3B, Rocky 3B, Classic 3B, yes, correct. Be more on the smaller sphere. Why? Because potential is basically we know that K Q by R, right, K Q by R. In for bigger sphere it will be K Q by capital R. Now, bigger the inside the sphere the potential is constant obviously, right. We know that every point inside the sphere potential is constant. So, no matter the size. So, in the case of smaller sphere obviously the entire charge is concentrated in a smaller region. So, obviously potential will be more in case of smaller sphere, right. Now, let us move on to the next question. For linear dielectrics, the ratio of dielectric polarization to the applied dielectric field is equal to. Very interesting question, little bit in depth question. Okay. Even though the answer can be guessable, easily guessable, but you need to know something to answer this question. Now, tell me the answer for this question. Mobility, dipole moment, epsilon naught times susceptibility, permittivity. Okay. Good evening, sir. Yes, Luffy. Rockies, less radii has more potential. Yes, correct, correct, correct. Your all of your explanations are correct. Luffy, answer the question. You are just chatting here. Chatting is not allowed. Only the answering and explanation is allowed. Okay. Normal regular chatting is not allowed. Now, let me. What is the answer to this question? One formula that you have to remember. If I write down the formula, you can answer it in just like 1 second. Okay. Varija, you have to mention the question number. Pooja 4C, Varija is also saying 4C, Classic 4C. Yes, yes, answer is 4C. Now, what is the formula that I was talking about? Polarization is basically epsilon naught chi E, sorry, not x, it is like chi E into electric field E. Okay. This is a vector quantity, this is a vector quantity, this is a dimensionless constant called electric susceptibility, which is different than that of magnetic susceptibility. So, P divided by E is basically, if you take the modulus, okay, then you get epsilon naught chi E. Okay. So, for the linear dielectrics, the ratio of dielectric polarization to the applied electric field is equal to epsilon naught times chi. So, this is the important formula. If you are preparing for KSET exam, there was one question based on this formula where they asked you to calculate chi E for one given material. So, this formula you have to remember very well, right. Now, next question, question number 5, slightly informative question. If you know the answer, you can answer it, otherwise a little bit difficult to calculate the dimension of electric polarization. So, in the previous case we have seen the polarization. So, the same polarization, what is the dimension of that? Please answer it. Please answer this question quickly. Anyone. Anup Patil, sir, we did not get the notes of previous classes. Yes, Anup, I am aware of that. Once we have at least 15 classes, because we share it directly via links, it is difficult for us to share individual lectures. So, what we will do, once at least 15 classes are over, we will share in bulk, okay, and at the say 15 classes, then again 15 classes in total, including physics, chemistry, maths, bio. Once we have a slightly longer number of notes, we will share it. So, again once it is done, at the end of the series you will get all the notes, do not worry about it. Okay, you will get the notes. Okay, 5D, Pooja saying 5C, Varija saying 5D. No, not C, not D. So, it is actually option A. Okay. So, I hope that clears your doubt. Yes, Classic mentioned it correctly. Classic mentioned it correctly. Anup, I hope that clears your doubt. We will give you the notes, do not worry. Okay. Since we share it via Google Drive link, that is why individual links sharing is a little bit difficult and tedious. So, once all the lectures are done, at least 15 lectures are done, we will prepare a drive for you and we will share the link. Okay. Now, 5 dimension. Okay. So, this is the option A is the correct answer. You have to remember this. Okay. In case you forget, you can check the last in your textbook, in your NCERT book. Okay, there is a dimension table in the end of the each chapter. Okay. At least try to remember at least those dimensions. If you have followed my decode NCERT during that series also, I have highlighted what are all the important dimensions that you have to remember. This is one of the dimension that you have to remember. The correct answer is option A. Now, now there is something big is coming, okay, to all the KSET aspirants 2025. There will be soon be a launch video 26th of January. So, do not miss that out. I request you 26th of January there will be a big announcement from our channel. So, on that day Sunday, okay, evening, okay, our director will come and give you some update on that. So, I just give you the hint that is about KSET students. So, stay tuned for this big announcement. Okay. Now, let us move on to the next question. Question number 6. Yes. The electric potential at the surface of a charged spherical shell of radius 10 centimeter is 20 volts. The electric potential at the center of the shell is. So, very interesting question. The electric potential at the surface of a electric shell, easy question, simple question. At the surface of the spherical sphere is 20 volt. What is the potential at the center? Okay. Six A, 6C, 6A and 6C. People are confused between 6A and 6C. So, let us see. So, this is talking about what? Potential, not electric field. So, potential inside a conductor is always constant up to the surface. Up to the surface potential is always constant, whereas electric field inside is 0. Just from the surface, outside the surface, it gives you some value. Okay, exactly on the surface there is a discontinuity, discontinuous function, but inside the sphere there is no doubt it is 0. Okay, and electric potential is constant up to the surface. Okay. So, electric potential no matter whatever is on the surface, the same value should be at the center. So, they will have the same value, right. So, electric potential will be constant. So, that is 20 volts. So, those who have answered 20 volts are correct. Those who have answered 6A, unfortunately Anup, Rocky, you are incorrect. Okay. Classic, Pooja and Varija, you are correct. Okay. Now, let us move on. Where is Kannadiga, my favorite student? Question number 7. The electric field at a point which is very close to the surface of a charged conductor with surface charge density sigma is. Okay. Another easy question, if you know the formula you can answer it like flash. So, electric field near a charged conductor, very long, infinitely long charged conductor, or very close to the charged surface, both are correct. Okay. Same formula. If you are considering point very close to a charged surface, or if you are considering electric field due to an infinitely long charged surface, both are correct. same formula is there, okay, charge conductor that is. So, what is the formula for that? 7b classic 7b, Pooja is saying 7a. So, this is a conductor, okay. So, there are two values, if it is not a conductor then one of them is correct, if it is a conductor then one of them is correct, okay. So, you have to be careful while answering it. One of the answer is correct, obviously either option A or option B is correct, these two are just wrong answers. So, that much hint I give you. Now, think one of them is correct if it is a conductor, one of them is correct if it is a, if it is not a conductor, okay. Now, what is the difference between conductor and non-conductor? Conductor can have electric field on this side as well as this side, okay, because it is a conductor. So, some charge will reside on this surface, some charge will reside on the other surface. But if it is a non-conductor, then it will have electric field only on the electric charges only on the one surface, whichever is the charge surface. So, only on that side you will calculate the electric field, okay, that is the difference. Okay. So, electric field due to a insulator or a single charge surface is basically sigma by epsilon naught, but when you are considering two charge surface, it is basically divided between two surfaces. So, here sigma by 2 epsilon naught, here also sigma by 2 epsilon naught. So, correct answer is option A. Okay. 7A Pooja is only correct, classic is incorrect. So, this is correct if you are considering only a single charge surface, okay. For conductor it is always divided into two halves, that is why it is sigma by 2 epsilon naught. Now, easy question, the energy density between plates of a charge capacitor is given by, anyone, whoever is watching please respond quickly. The energy density between the plates of a charge capacitor is given by, question 8, the energy density, okay, anyone, classic, what is just saying 8C, classic is saying 8A, Pooja 8C, now a new student came, Shaukat Ali saying option A. How did it happen? Streaming. Hello, can you see me now? Hello students, please respond if you are able to see me. There was some technical issue, that is why the streaming got stopped in the middle. Please response. Overgeared gaming is here. Answer B is the answer. I have seen that answer from some students have answered Pooja, Varija, Anup. Okay. The correct answer is option C. Unfortunately, when the video got stuck, I was not aware the video was stuck and I was giving my lecture. So, many of you have not seen my explanation. So, let me give you the explanation once more. The correct answer is half epsilon naught E square. This is the energy stored, energy density. So, the question is energy density, this is not about energy stored. If it was about energy stored, then the correct answer would have been half C V square. Energy stored in a capacitor is half C V square. Energy stored is the energy per unit volume, which is basically stored in form of electric field, which is very very important. So, energy stored per unit volume, that is energy density, is given by half epsilon naught E square. The derivation for that is given in your book. Sudarshan, can you tell me when you will start first PU revision classes? Sudarshan, definitely we will try to do one quick revision of first PU revision classes for KSET. Okay. KSET revision will definitely happen, but not yet. Okay. We will start one shot videos for KSET, that is on our pipeline. Also, we have taken a poll from the students. Based on that, we decided that we will conduct one shot videos for KSET. Soon happen. Okay, do not worry about it. Now, during that time, we will do one shot revision for first PU. Okay. Pratima, yes, Pratima, welcome Pratima. Pratima is here now. 8C is the answer, correct answer, yes. Now, let us move on to the question number 9. I have also I already moved into question number 9 when the video was stuck. Okay. So, I already moved in from question number 8 to question number 9. Sorry for the delay. So, 9 is an interesting question. The potential energy of an electric dipole placed in a uniform electric field is minus P dot E, B minus P cross E, C half C V square, D is half epsilon naught E square. Now, in the question it is talking about electric dipole, but from the previous question or from our previous knowledge, we already know these two things are related to a capacitor. So, these two cannot be the correct answer. So, we can simply ignore these two options. So, it is a 50% answer. So, what do you say in KBC, they give you some 50-50 options, right. So, already I have deleted two wrong options, you have to choose the correct answer from option A or option B. Shaukat Ali is saying 9A, Pratima saying 9A, Varija is saying 9A. Varija, option D is also for energy stored, but that is energy density, right. You have to divide it by the volume, then only you will get that answer. Okay. Energy stored per unit volume, that is what I said. So, that is why it is called energy density. Energy density depends only on electric field and the permittivity of the medium. Okay. Pratima, Shaukat Ali, all are saying 9A. Yes, 9A is the correct answer. So, one more important thing is that potential energy is a scalar quantity. Okay, even if you are confused, you should remember that these two are for capacitor. So, you can ignore them. Next is this is a vector quantity. Now, potential energy is a scalar quantity. So, answer must be a scalar quantity. So, answer should be P dot E. Okay, as simple as that. Minus P dot E, they might give you a confusing option in final exam plus P dot E, but you have to be careful. Potential energy of a dipole is minus P dot E. Okay. So, this one you have to remember the sign and this dot product. Okay. Now, next question, question number 10. electric dipole is placed in a uniform electric field, the dipole moment makes an angle theta with the electric field. For what angle theta is the potential energy of the dipole maximum? Now, answer question number 10. An electric dipole is placed in an uniform electric field. So, there is an electric field. Hello, can you see me now? Sorry, Shaukat Ali, there are some technical issues happening today in the studio. I already explained the answer. Right, it was not lagging, it was there due to some reason the camera is getting stopped. Okay, that is why you are facing this issue. I hope it will not happen again. I will after the lecture is over, I will ask my technician to check it once more. Okay. Now, let us see why this is 180 degrees, because from the previous question or from the theory that we know that potential energy is U is equal to P dot D, right, P dot E minus P dot E. Now, either it will be 0 degree or 90 degree cos theta is 0. So, obviously 90 degree is not possible. Only thing is possible is that either 0 degree or 180 degree. Now, we have to remember that there is a negative sign. So, negative sign means if we can make the entire value positive, then only it makes sense. Now, potential energy will be positive if we can choose the cos theta to be minus 1. So, that means theta is basically 180 degrees. In that case, you get potential energy to be plus P is obviously greater. So, answer is not 0 degree, but 180 degree. I can see many of you have given the correct answer. Yes. Now, next question, question number 11. Capacitance of a capacitor is defined as C equals to Q by V, a factor on which the capacitance of the capacitor depends on charge Q, geometry of the conductor, potential difference V, all of the above. Very, very interesting and very understanding level question. Question cannot be answered easily if you do not understand the formula is given C is equal to Q by V, right. Now, they have asked you on which factor the capacitance depends. Is it dependent on Q, is it dependent on V, is it dependent on the geometry, or is it dependent on everything? Pratima Varija, 11 B, yes, yes, option B is the answer. Now, if you read a detective novel, okay, some poor quality detective novel, they show many suspects. Okay, eventually, some person, some unknown person who comes out to be the killer. Okay. So, he has a very few less moment in the story or in the novel, okay, and but at the end he was pictured as the killer. So, this is like that. Okay. So, capacitance depends on charge, voltage, but it does not actually its value does not depend on charge or voltage. Okay. As much charge you will store, based on the charge, the voltage will automatically adjust, so that this value C remains constant. Okay. C depends on three things: K, A, epsilon naught by D. Okay. It depends on area, it depends on the distance between the plates, and it depends on the whatever you have kept in between the capacitor plates. So, basically capacitor capacitance depends on the geometry, that is area, distance, etc. Not only that, in case if they have mentioned not mentioned parallel plate capacitor. So, it can be anything. So, it can be a spherical capacitor, it can be different shape of the capacitor, right. So, definitely it does not depend on charge, it does not depend on V, it depends only on geometry of the conductor. So, this is a confusing question if you are not aware. Now, question number 12, capacity of a parallel plate capacitor can be increased by increasing the distance between the plates, increasing the thickness of the plates, decreasing the area of the plates, decreasing the distance between the plates. Now, answer it. Answer quickly, quickly. Twelve D, decreasing the distance between the plates. Yes. So, if this is the capacitor, okay, either you can increase the area. Okay, we have already seen the formula K A epsilon naught by D, right. So, either you can increase the area or you can decrease the distance. So, here they have not given any option related to increasing the area, only they have given the distance. Thickness has no relationship of the plates, thickness of the plates is immaterial, only thing is decreasing the distance between the plate, that is the correct answer for this. Okay. Shariful, yes, Shariful, your answer is also correct. Not Shariful, sorry, Shaukat Ali. Yes, yes, decreasing the distance between the plates. Yes, Pratima. Now, question number 13. So, I am checking if my stream is getting stopped every time. The potential energy of a capacitor stored in the dash between the plates of the capacitor. Again, I have discussed this answer in my previous solution. So, if you are following me, then you should be able to answer this. So, the potential energy of a capacitor is stored in electric charges, electric field, magnetic field, current. Now, tell me the answer. Two of them are actually not related to this chapter, not related to the concept. So, you can ignore those two options, other options you have to be careful. What is you saying 13 B, any more, anyone else? Yes, Pratima, Shariful is also, Shaukat Ali is also saying 13 B. Yes, 13 B is the answer. We know that potential energy, energy density is half epsilon naught E square. So, energy density is basically given by half epsilon naught E square. So, potential energy is stored in the form of electric field. So, more the electric field, more energy it has. So, the potential energy stored by electric field. Now, next question. This is a long question. So, read it carefully before answering. Which of the following correctly describes the behavior of a polar and non-polar dielectrics in an electric field? Okay. So, option A, both polar and non-polar dielectrics have permanent dipole moments, but only non-polar dielectrics align in the external field. Okay. Polar dielectrics align their dipole moments with the external field, while yes, sorry, thank you Pratima for notifying me. Okay. So, the question is, which of the following correctly describes the behavior of polar and non-polar dielectrics in an electric field? Option A, both polar and non-polar dielectrics have permanent dipole moments, but only non-polar dielectrics align in the external field. Option B, polar dielectrics align their dipole moments with the external field, while the case of non-polar dielectrics, a dipole moment is induced in response to the field. Non-polar dielectrics align their permanent dipole moments in an external field, while polar dielectrics remain unaffected. Polar and non-polar dielectrics behave identically in the presence of an electric field, showing no difference in the polarization. Okay. Now, answer this question. Yes, very difficult question, but question is long, but not difficult in a sense. If you have studied little bit about polar and non-polar molecules, you can answer this question. Question language is little tricky in terms of explanation they have given, but actually if you know about polar molecules and non-polar molecules, then you can answer it. So, first of all, what is a polar molecule? Polar molecule is basically where the centers of positive and negative do not coincide, right. So, polar molecule means normally in general their centers do not coincide, that means they already have a permanent dipole moment, but when you consider a material, okay, they align themselves such that they are randomly distributed, such that the total dipole moment is 0. They are randomly oriented, but total dipole moment of the system is 0, but there is a dipole moment of the molecules. Now, if you apply an external electric field, what happens for polar molecules? They align themselves. According to the external electric field. So, they becomes negative to positive in the direction of electric field. So, all the dielectric they align themselves based on the strength of the electric field, whereas if you consider non-polar, by default they are like this, plus and minus centers coincide. Okay. When you apply external electric field, what happens? Now, their centers get separated. So, they respond in the response to the external electric field, they get separated and you get this separation. So, they in general they do not have any dipole moment, but based on the external electric field they give the response based on the external electric field. So, option D, even though they are very tempting, option D is actually not correct. Correct answer is option B. Okay. So, I can see some of you have answered, only Shaukat Ali has answered 14 B. Yes, correct answer is 14 B. Okay. Now, next question, question number 15. An electric dipole is placed inside an insulating spherical shell. Pick the wrong statement, very very important wrong statement you have to pick. What is the question? Inside a spherical shell, you have a shell, okay, you have placed a dipole. So, suppose this is plus q, this is minus q. Now, what is the answer? Net charge enclosed by the shell is 0. Sphere acts as an equipotential surface. Electric flux through the sphere is 0. Electric field is not uniform across the surface of the spherical shell. Easy question if you know the how to think about it, right. Quickly. Aditya Bibhuti official, you have to mention the question number. Aditya Bibhuti is saying option D, electric field is not uniform across the surface of the spherical shell. Now, let us discuss. Net charge enclosed by the shell is 0. Obviously, the net charge enclosed by the shell is 0. Total charge is plus q minus q, that is 0. Sphere acts as an equipotential surface. Okay, there is no charge. So, equipotential surface, no condition for equipotential surface. Okay, they are at different distances. So, it will not it will act as a equipotential surface because total charge inside the sphere is 0, combined charge, right. Electric flux through the sphere is 0, electric flux through the sphere is 0. Again, this is also correct statement. Now, electric field is not uniform across the surface of the spherical shell. The total charge inside the sphere is 0. So, electric field will be 0, which is uniform, right. So, Gauss's law says that E is equal to E dot ds. So, assuming that E dot ds q enclosed by epsilon, q enclosed is 0. So, only thing is possible is ds cannot be 0, only thing is E will be 0. So, electric field 0 electric field, even though it is 0, that does not mean it is not uniform, right. So, 0 is an uniform number. So, electric field will be 0 across the surface, right. Now, next question. Pratima, yes, Pratima, 15D was the correct answer. Aditya, yes. Varija, yes. Now, this is also an interesting question. Okay. The following graphs show the variations of two physical quantities with distance r from the center of a uniformly charged spherical shell. Identify the two graphs. Now, this question can be an easier version of K-set question as well. This question can come if the if this is chosen as an easier version, easier question. Okay. So, from this chapter 3 to 4 question comes in K-set. So, out of them at least one of them are easy. Actually, this question might come as a easy question. The following graph shows the variation of two physical quantities distance r from the center of uniformly charged spherical shell. First graph shows the variation of E versus r and second is V versus r. So, they are saying there are two graphs. First graph is showing E versus r, second one is showing V versus r. The first graph shows the variation of V versus r, second is E versus r. Both graph shows the variation of V versus r. Both graph shows the variation of E versus r. Again, these two options cannot be correct. So, 50-50 is already applied. So, obviously, and all the graphs according all the options, this is the r axis, right, variation of r, that means this is the r axis. Now, what is the y axis, that we have to determine. 16b, 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 yes, 16b is the answer. First graph shows the variation of V versus r. We know the V is constant inside the spherical shell. Definitely, this is V versus r. This represents constant. So, that is why it is V versus r. Okay, and this represents 0. So, electric field is 0 up to the surface. From the surface, it suddenly gives you a constant, gives you a decreasing value. So, this is a electric field E versus r. Okay. So, there is a discontinuity, I was talking about discontinuity. So, there is a discontinuity. Okay. Electric field is discontinuous, whereas electric potential is continuous on the other hand. Okay. Okay. Now, next question. Statement. Now, this is the statement based question. Okay. Statement 1, the electric field inside a conductor is 0. Statement 2, all the charges resides only on the surface of the conductor. Okay. Both statements are correct and statement 2 is the correct explanation of the statement 1. Both statements are correct and statement 2 is the not correct explanation of the statement 1. Statement 1 is correct and statement 2 is wrong, statement 1 is wrong, statement 2 is correct. Now, obviously, electric field inside the conductor is 0, I will already discussed it, electric field inside the conductor is 0. So, definitely this is the correct statement. Okay. All the charges resides only on the surface of the conductor. This is also true. We know that if you give charge to a conductor, all the charges behaves like a floating ball and they come out to the surface. This is also correct. So, both statements are correct. So, you have to choose whether this correctly explains statement 1 or not, right. Let us see. 17A, 17A, Aditya is saying 17C. Why Aditya? Why 17C? Both statements are correct. Statement 2 is also correct. The charges only reside on the surface of the conductor. If it is a conductor, charges will only stay on the surface. If it is a insulator, then charges can stay inside the surface as well, but if it is a conductor, then it will the charges will always stay on the surface. Okay. And basically, if you apply Gauss's law, okay, because the charges are inside, okay, electric field has to be 0 inside, right. The Gauss's law says that it only depends on the charge enclosed. So, basically this is the correct explanation. So, both statements are correct and statement 2 is the correct explanation for statement 1, right. Aditya, rest of the students Varija, Pooja, Pratima, they have all answered it correctly, but Aditya, I hope your doubt is cleared. Both statements are correct, and why it is correct statement? Because it can support the Gauss's law that comes from the fact that electric field depends only on the charge enclosed by it, right, electric flask. From there you can explain it. Now, this is another interesting question, slightly hot level question. An imaginary sphere of radius r is drawn around a charge q. Keeping the charge q at its center, the work required to move the test charge small q from point A to point B. So, point A is given here, point B is given here, right. You have to take a charge and you have to move it here. Okay. So, what is the work done that you have to do? So, they have said you have a small charge, say small q, you are moving this small charge from here to here. What is the work done? The distance is obviously, total distance is this. So, this is r, this is r. So, total distance is 2r. Now, answer this question. Hello Karnataka, late, I was asking about you few moments back. Yes, Varija, you have guessed it correct. You have guessed it correct, and Pooja already answered it. Aditya also answered it. Yes, yes, yes. So, because it is an equipotential surface, it does not matter. So, I tried to confuse you by giving value 2r. Actually, there is no work done because it is an equipotential surface. The distance from the charge in both cases are equal. So, whatever the potential at point A, the same potential is at point B. So, you can say that all the points on the surface of this sphere are at equal potential because they are all equidistant, right. So, from there you can say the potential is 0, sorry, work done is 0. Okay. The work done in an equipotential surface is 0. So, none of you have actually fallen for my trap, but I am happy to see that. Now, consider the following statements, another statement based question. The equipotential surface at a point is always normal to the electric field at the point. Option 2, if the electric field were not normal to the equipotential surface, work has to be done in moving a test charge on the surface. Okay. So, again same options, both statements are correct and statement 2 is the correct explanation. Both statements are correct and statement 2 is not the correct explanation. Statement 1 is correct and statement 2 is wrong. Statement 1 is wrong, statement 2 is correct. Aditya, yes, Aditya, your answer was correct. Karnataka, now answer. You are late for the class. 19A, Varija 19A, Aditya 19A. Yes. So, both statements are correct. So, if we know that suppose this is an equipotential surface, the electric field will be always perpendicular to the equipotential surface, and in case there was some component of electric field, then on the surface of the equipotential there will be some component. Okay. So, suppose the electric field is not normal, suppose. Okay. So, there will be a component in the perpendicular direction, there will be a component in the parallel direction. Now, this will cause the charge. Suppose now I keep a charge, to move this charge opposite to the electric field, I have to do some external work, which is not possible in the surface of an equipotential surface. All the points are of equal potential, that means work done will be 0. So, that is not possible. So, this will not possible, only thing that is possible is the it has to be normal. Okay. Now, next question, I am giving you some time. See this question, the equivalent capacitance of the combination. So, these two capacitors are connected in series and the entire combination after that this is connected in parallel. Okay. So, I am giving you 1 minute, try to solve it and quickly tell me the answer. Yes, Karnataka, answer was 9A. Pratima, 19, you have not mentioned 19. Varija already know the answer or you have solved it? Aditya, Vibhuti 20A, no, not 20A. So, first, yes, first part is easy, that both of them are connected in series. So, in case of series connection, what is the two capacitors are in series. Two capacitors in series, suppose I replace them with a intermediate capacitor, say C dash. So, what is the value of C dash? We know that that is nothing but C1 C2 divided by C1 plus C2, right. This one we know, this is easy. So, two capacitors in series or two resistors in parallel, we can calculate it using this shortcut formula. Now, this one is connected in parallel. So, parallel means, so total C equivalent will be right, C dash plus C3, not 1 by C3. They are connected in parallel. In case of capacitance in parallel, they gets added, right. So, C dash plus C3. So, C dash is C1 plus C1 C2 divided by C1 plus C2 plus C3. So, if you solve it, C1 plus C2. So, C1 C2 plus C1 C3 plus C2 C3, right. So, this is the correct answer, option T. Shubmangala answering option A, Ujjwala B, Aditya, no, you are all wrong, only Varija and Pratima as usual are correct. Karnataka answered one question, then he left. Anyway, let us see the next question. The angle between equipotential surface and the electric field is, another easy question. So, what is the angle? We have just seen. Same question came in question paper, okay, that is why you are able to answer in your midterm, not midterm, I guess in your pre-board exam, right. That is why I thought you are answered very quickly. Answer Varija is saying option A, the angle between equipotential surface and just now we have seen that equipotential surface and electric field they are always normal. So, the angle is always 90 degrees. Okay. Even though there is some doubt about it, I will not discuss doubt, then you will get confused. Anyway, this is also from I think either last year question paper or last year preparatory question paper, which is the total charge on the parallel plate capacitor. Total charge on the parallel plate capacitor. Pooja saying 21, 21 is done, 21A is correct, yes. Now 22. Now 22. What is the total charge on the parallel plate capacitor? Okay, total charge in a parallel plate capacitor is basically plus Q minus Q, that is 0. Okay. So, the total charge in a parallel plate capacitor is 0, charge of an capacitor is Q, but total charge of a capacitor is always 0. Okay. But we mention when mentioning the charge of a capacitor, if they have mentioned total charge, then obviously it will be 0. Okay. Not 22A, total charge is Q minus Q, that is 0. You have to remember total charge of a capacitor is 0. There is a beautiful line written on your NCERT book. Even though the total charge of a capacitor is 0, we mention the charge of a capacitor while considering, we only consider the positive charge. Okay. So, if they say what is the charge of a capacitor, you have to mention Q. If they say what is the charge, total charge of the capacitor, total charge is always 0. Yes, Pooja is answering, I think answered it correctly. Okay. Varija is not to 2Q. Okay. Yes. Now, next question is question number 23. This is a small numerical question. I think this is from your model question paper. The capacitance of a capacitor is 6 times 10 to the power of minus 6 farad. Okay. It is connected to a 200 volt cell. The energy released on discharging it fully will be. Okay. So, what is that? So, energy, we know that energy stored in a capacitor is half CV square, right. You use the formula to calculate. Tell me quickly. So, half C is 6 into 10 to the power of minus 6 farad, 6 into 10 to the power of minus 6, V square is 200 whole square. 23B, 23B, 23A, 23A, 23A. Yes, let us see. Aditya maybe made a mistake, half 6, let me cancel this 3. Okay. So, it will be 3 times 10 to the power of minus 6 into 200 square is 4 into 10 to the power of plus 4. Okay. 2 zeros means 10 square, 10 square whole square is 10 to the power of 4. Okay. So, for 3 4s are 12 into 10 to the power of minus 6 plus 4, that is 12 into 10 to the power of minus 2, that is 0.12. Okay. So, 0.12 joule is the correct answer, right. Last year MCQ, yes, last year MCQ, I think, yes, last year question paper. If an n identical capacitors of capacitance C is connected in series, then the equivalent capacitance is easy question. So, n capacitors are connected in series. Okay. So, there are like n capacitors connected in series. What is the equivalent capacitance? What is the equivalent capacitance? So, suppose C, 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 all of them are C. Kannadiga is back 24B, and he deleted his comment because I know he is wrong. Pratima is correct, Shaukat Ali is correct, Shaukat Ali, no, Shaukat Ali, you are not correct unfortunately. Pooja is correct, Kannadiga now again answering with wrong answer. No, 24B is not not correct, it is 24C. So, all of them are connected in series, right. In case of series connection of capacitor, connection of capacitor, what is the equivalent capacitance? Equivalent capacitance is 1 by Ceq. Okay, let me clear the doubt about this. 1 by C plus 1 by C plus 1 by C plus dot 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 1 by C, right, n up to n, right. So, how many 1 by C's are here? N number of 1 by C's are here. So, total addition will be n by C. So, for example, if you add say 1 by x plus 1 by x 2 times, what is the value? 2 by x. If you add them 1 by x plus 1 by x plus 1 by x 3 times. So, what is the answer? 3 by x, right. Similarly, if you add same numbers n number of times, you get n by C. Now, this is 1 by Ceq, you have to take the reciprocal. So, Ceq is equal to C by n. Okay. So, C by n, remember this. Okay. This was taken from some old cassette paper, I do not remember the year, but this was one of the oldest cassette exam. Okay. That is why you might feel yes, Shaukat Ali, now you have answered it correctly, right. Now, let us see the next question 25. If a charge in a capacitor is doubled, then the capacitance is easy question, right. Yes, Varija, yes, for parallel combination it will be NC. If the previous question, if they ask you that there are n capacitors in parallel, this can also be possibly be asked. Okay, so, be careful. I have solved the series one. Now, in the exam if they ask you parallel one, that also is possible. So, be careful. Suppose you have n capacitors connected in parallel. Okay, now you have to add them. So, in that case it will be NC. Okay. Now, this is the previous question discussion. Now, this question, in charge of a capacitor is double, then what is the capacitance? Pooja Aditya is saying 25D, Pooja is saying 25A, and Pratima is saying remains the same, Varija is saying remains the same. Yes, actually it will remains the same, does not matter. C is equal to Q by V, but I already told you it does not depend on Q, it does not depend on V. Okay. Even though they are linked, okay, capacitor for a given capacitor is generally constant. Okay. It changes only with K A epsilon naught by D. Now, epsilon naught is constant. So, either you can change the dielectric medium between the capacitor plates, or you can change the area of the capacitor plate, or you decrease or increase the distance between the plates, only then the capacitance will change. Capacitance will not change by changing the charge. If you increase the charge, what happens is that, suppose you increase the charge to 2Q, then the voltage will also become 2V. So, that they cancel each other and the capacitance remains same. So, the voltage will adjust itself accordingly, so that total capacitance remains the same. Okay, that is the linked relationship. Only way you can change the capacitor is by changing one of these factors, 3 factors. Sorry for the, there is some issue is happening Aditya throughout the stream today. Unfortunately, we will try to figure it out once the lecture is over, because the lecture is going on, I cannot do anything. So, first is this question, at the surface of a charged conductor, the electrostatic force, electrostatic field must be either 0, parallel to the surface at every point, infinity, normal to the surface at every point. Pooja, is it still stuck? Can you not see me? Hello Pooja. I think it is now visible to everyone. Aditya, if you are not see me, if you are not able to see me, just click on the live on your YouTube, it will give you the live. Yes, equipotential. So, that means the it will be normal. Yes, equipotential means it will be normal to the surface at each and every point. So, not like this, it will be normal each and every point. So, you can join. Okay. So, normal to the surface at every point, not C. If anyone answered C, no, yes, 26 D is the answer. Yes, yes, correct, correct Pooja, correct Aditya, correct Pratima. Yes. Now, 27 we have up to 35. So, 8 more questions we have. So, solve it quickly before it gets stuck again for the next time. Okay, I want to quickly wrap it up. The electric field inside the cavity of a charged conductor is 0. This is known as, very easy question. So, inside a conductor there is a cavity, inside that cavity electric field is 0. So, what is the name of this thing? So, charged conductor, conductor has some charge, but inside the cavity, this is the cavity, okay, electric field is 0. What is the name of this? Very easy. (27 D, 27 D, 27 D). Yes, it is called electrostatic shielding. Okay. So, do not waste too much time in this easy question. 28, dash dielectric develops a net dipole moment in the presence of an external field. Okay, only polar, only non-polar, both polar and non-polar, none of them actually. It is not no, it will be none of them. Okay. Varija is saying 28A. Any other answer? So, if you have seen my dielectric explanation, so dipole moment, they have a dipole moment at molecular dipole moment is there in case of polar molecules. Okay, their centers do not coincide, but in case of non-polar their centers do coincide. But when you apply external electric field, what happens is that the dipole moments, dipole moment of a polar gets aligned. So, negative positive, and in case of non-polar also under the effect of external electric field, they are also getting aligned, minus plus, right. So, both dielectric develops a dipole moment in the presence of external electric field. So, option C is the correct answer. Pratima also answered A, Shaukat Ali also answered A, no, option C is the correct answer. Both polar and non-polar dielectric develops dipole moment under the presence of an external field. So, presence of an external field means it will also develop a dipole moment. It is already having a molecular dipole moment, but they realign themselves, so that the total dipole moment is not 0. So, non-zero dipole moment in case of polar, non-zero dipole moment in case of non-polar as well. So, both will have dipole moment, right. Now, next question, question number 29. Aditya answered it late. I am now suspecting if you have seen the answer or not. Anyway, 28C is the correct answer. Which of the following is discontinuous across the surface of a spherically charged shell? Only field, only electric potential, both electric field and potential, only gravitational field. Okay. So, spherically charged shell, okay. Somehow the gravitational field is here. So, gravitational field has nothing to do with the charge sphere. So, you can ignore this answer. So, you can option should be either between A, B and C. 29C, Varija is fast now. Both electric field and potential. Think. Pratima is also saying both. So, let me give you the graphs, just you saw the graph, right. So, this is for the electric potential and this is for the electric field. This is for the electric field. Now, you tell me which one is the which was has some continuity, which one is not continuous. What is the meaning of continuity? Continuity means, suppose this is the surface, right, radius. If you go from this side, whatever value you will get, if you come from this side, you get the same value, right, limit, right. If you have learned the continuity in mathematics, if you travel from this side along the of the curve, okay, whatever value you will get, the same value you will get if you come from this side. Now, in case of electric field, this is potential. In case of electric field, when you approach from this side, you get some constant value, but when you get from approach from this side, you get E is equal to 0, right. But from this side, you get E is equal to k q by r square, right. So, at this point from both sides, if you approach from your left hand side or basically inside the sphere or outside the sphere, you get two different values. So, definitely electric field is continuous, but if you come for, if you consider this surface, okay, if you approach from this side also, you get k q by r, and if you approach from this side also, you get k q by r. Okay. So, electric field is constant inside the sphere. So, from right from your left hand side, you get this k q by r, and if you apply the formula for to calculate on from the outside, you will get this same value. Okay. So, that means electric potential is definitely continuous at the surface, but electric field is not continuous. Okay. Which of the following is discontinuous? Only the electric field, not the potential. Potential is continuous, right. It is not about inversely proportional, it is about continuous or discontinuous, right. So, continuity of a function is not dependent on what, how does it depend on it, right. It depends on how the function is related to it. Okay. So, the you have studied that in the function chapter, right. 29 A is the correct answer, yes, because electric field is discontinuous, whereas electric potential is continuous. Next question, question number 30. After this, we still have 5 more questions. Okay. Quickly. Potential due to a charge q at its own location is, interesting question. Potential due to charge q at its own location. A. Keshav, hi sir, hi Keshav. So, we have already solved a lot of questions. 30A, 0, potential due to the charge q at its own location. What is the formula for potential? Potential is sorry, not potential, energy. Electric potential is k q by r. Now, at this own location means r equals to 0. So, what will happen if you put r equals to 0? What is the value? Shariful, yes. No, R becomes 0 means it is not 0, 1 by 0. Potential is 1 by 1 upon R, right. So, 1 upon R means it will become infinity. 30B is the answer, right. R is 0 means it will be infinity. No Pooja, no Aditya, Keshav answered it correctly. Yes, it is infinity. Okay. Now, next question 31. Okay. The capacitance of an air capacitor is C naught. A dielectric medium of dielectric constant K is inserted between the plates. The new capacitance will be, very interesting question. So, you have to remember that capacitor is given by K A epsilon naught by D when there is a capacitance is present. Now, you tell me the answer. Is potential difference defined for itself, sir? Potential difference is something different, potential is something different. Potential difference means the work done required to move from one point to another, that is the potential difference. Potential is the work done required to bring from infinity to that point. These are the two different things about potential and potential difference. Okay. If your starting point is infinity, then whatever total work you are doing, that is potential, that is the potential, whereas potential difference means within the field, if you take one point to another point, that is called potential difference. Okay. 31 C, 31 C, let us see. 31A, Deepa is saying 31A, Pooja is saying 31D, Aditya 31C, Pratima 31C, Varija is saying 31D. If you are saying that potential difference is defined for the point at the center, it is undefined, but infinity is obviously an undefined quantity also. Okay. So, that is why even though Coulomb's law is not applicable at the center, you can mathematically calculate the potential which turns out to be infinity. Okay. Now, so C for air, that is C naught, is given by A epsilon naught by D, right. So, this is C naught when there is a air capacitor, only air is present. For air K is equal to 1, for air K is equal to 1, right. Now, if you add a dielectric of constant K, then that is C k. So, C k is nothing but K into C naught. If you take this, this is nothing but C naught. So, this will be K into C naught, not C naught by K. Okay. So, it is K C naught. Now, there was in the past there was a question in K set where they asked is which dielectric it is C, and if you remove the dielectric, what will be the capacitance. In that case, it would have been C by K. Okay. If you remove the dielectric, it will become C by K. If you add the dielectric, it will become C into K. Okay. Next question, easy question. Electric potential due to a negative point charge at a distance r is. So, what is the charge? Charge is negative and distance is 1 by r. So, what is the formula for electric potential? So, it is about electric potential due to a negative charge, not a dipole. Keshav, which one you are saying, Keshav? Please mention the question number. 31D is correct. Varija 32D. Negative and varies as 1 by r. So, yes, V is equals to K Q by r. Now, we know that Q is negative, given negative here. So, V will be minus K mod of Q by r. Plus Q is negative given. So, we can take that negative sign out here and we can take the modulus of the charge. So, negative and varies as 1 by r. So, obviously, 1 by D, option D is the correct answer. Okay. So, be careful, the charge is negative, electric potential is normally is given by this formula, it is not a negative by default. Okay. So, you have to put the negative sign because the charge is given negative. So, that is why it is negative and varies as 1 by r. Next question 33 quickly, 2 more questions after this. Values of electric field E and electric potential V at any point on the equatorial plane of an electric dipole are such that. So, electric dipole is there, say plus q minus q, and equatorial plane is there. Now, what is the relationship between is there, what is electric field here, what is electric potential here. Okay. Shaukat Ali 33D, E is equal to E not equal to 0, V not equal to 0. Varija is saying 33B, whereas Pooja 32D, Shaukat Ali, someone actually correct. Yes, Aditya answered 33C. Yes, 33C is the answer. Remember Varija and Shaukat Ali, that electric field is obviously not 0. Electric field, we have already calculated the formula for electric field for previous chapter, right. We calculated the electric field, right, like this. Electric field is not 0, but what about electric potential? Electric potential on the equipotential equatorial plane, electric potential both have the same distance. Suppose this distance is r1, this is r1, both charges have the same distance. Now, electric potential is a scalar quantity. So, k q by r1 plus minus k q by r1, right, one of the charges is negative. So, electric potential will turn out to be 0. Electric field is not 0, obviously. Electric field, for that we have calculated the formula, that is, it varies with 1 by r cube, right, and it is negative because dipole moment is in the negative to positive direction. So, electric field is negative and it varies as 1 by r cube. So, electric field is not 0, that much we know, but electric potential will always be 0 across any any point on this plane, because distance are equal, that is it. So, on the equatorial plane, electric field is not 0, but electric potential is 0. Okay. Question number 34, which of the following is the unit of capacitance? Pooja changed that answer 33D, then she changed to 33C. Varija answered it wrong, Shaukat Ali also answered wrong. Now, this is easy question. I will not wait for your response. This is very easy question. I know all of you will be able to answer it. The unit of capacitance is farad. Okay, Coulomb, Volt, Tesla are not unit of capacitance. Next question 35. This is an interesting question. For this I am giving you 1 minute. Okay, spherical conductor of radius r is carrying a charge plus q. The ratio of the electric potentials corresponding to the point on the surface of the conductor and a point at a distance 2r from the center of the conductor are in the ratio. So, there is a spherical conductor. Okay. Now, they are saying the electric potential on the surface to a point at a distance 2r. Okay. Okay. So, this is r, this is this distance is 2r. So, say the potential on the surface is V1, potential here is V2. So, what is V1 is to V2. (35D), 35A, 35A. So, let us see. So, what is V1? V1 is K Q by R. So, total charge on the surface, say Q. What is V2? V2 is K Q by 2R, right, on the surface. This is surface, equipotential surface. So, that is why we know this is the formula, and any point at a distance 2r can be calculated using this formula. So, what is V1 by V2? V1 by V2 is K Q by R divided by K Q by 2R. So, this 2R will go up. So, 2 by 1. So, V1 is to V2 equals to 2 is to 1. So, 2 is to 1 is the answer. Option B is the correct answer. Okay. Varija, why you answered option D? Option D is not at all possible, right? Electric potential, not electric field. Okay, this ratio of electric potentials, not electric field. If it was electric field, 4:1 would have been the correct answer. Okay, but they have asked about electric potential, so electric potential is only 2:1, right? So, be careful what ratio they have asked you to find. Okay. Ratio questions are very common in the competitive exam, because students often get confused about the ratio. So, V1 is to V2 you are finding. Okay. They have said the first, what is the first quantity? First quantity is the on the surface is first, second is the conductor and a point on the distance toward from the center. Okay. So, V1 is first is to V2. Okay. So, V1 is that we are trying to find. Okay. That is why option A is not correct, option B is correct. So, whenever you are answering ratio based questions, you have to be careful. Okay. Now, I have reached the end of the lecture. Today's lecture was slightly disturbed with the all the disturbances that we have faced. I will try to rectify it very soon. Okay. And we will meet with a new chapter on Friday. Okay. This Friday will be physics class. We will study current electricity. So, I will hope that I will see more of you are live and interacting with me. Till then, bye.